Okay, so here we go. We're going to show you how to sketch a problem using the standard form of the equation. The first thing we need to do is find the vertex. How do we find the vertex when we're not in vertex form? Well, I'm going to put it in vertex form, and this is how I'm going to do it. I'm going to rewrite this, and I'm going to rewrite this with the x squared and the x value inside the parentheses, and the c value on the outside of the parentheses. Now, you should notice right off the bat, this kind of looks like the vertex form. The only difference is we have a squared x on the inside of the parentheses and no square on the outside. So we need to fix that, and I'll do that in just a second. The other thing I want you to notice is yesterday we talked about the a value. The a value in vertex form and the a value in standard form are equal to each other. In other words, the coefficient on x squared, whether we're in vertex form or in standard form, is the same number, and there is no coefficient to x, so it's an implied 1. So our a is 1. So you could put a 1 out here. It's not necessarily necessary, but that's the x value of the quadratic equation, or this quadratic function. Okay, the next thing we have to do is complete the square. This goes back to Algebra 1. I hope you remember how to complete a square. To complete a square, you take half of the b value. So we want the c value inside the parentheses, which is going to be half the b value. And since it's a negative, I'm going to have a negative here, squared. Well, half of -4 is -2. -2 squared is 4. So I'm going to have to add 4 inside the parentheses to make this a perfect square inside here. Now, I added 4 here, so I'm going to have to subtract 4 outside to keep it balanced. See, I added 4 here, so I subtracted 4 here. So I have added a net 0 to the equation. I just put 4 in here to make this a perfect square, and then I took it outside the parentheses to keep my equation balanced. Next, I go ahead and rewrite this in a perfect squared. When you have a perfect squared trinomial, all you do is you take the x squared value and make it x. You take the square root of the c value, which is 2. And how do I know it's negative? Because -2 times -2 makes -4. So if this is a positive 4, then this would be a positive 2. We have a perfect squared, so I have a squared right there. And I have 8 minus 4, which is 4. I am now in vertex form. And I can tell the vertex is 2, because what makes this 0? 2. And the y value is 4. So the vertex is 2, 4. Okay, that's one key point. The next key point we're going to want is the y-intercept. The y-intercept is very easy to find when you're in standard form, because by definition, the y-intercept is when x is equal to 0. Well, if I put in 0 for x squared, I get 0. If I put in 0 for -4 times x, I get another 0. 0 minus 0 plus 8 is 8. Remember, x was 0, y is 8. So now I have 2 points on the graph. I need a third point. Because we do not have a line, we have a curve. When you're sketching a curve, you need a minimum of 3 points. When you're sketching a line, you only need 2 points. So how can I find a third point? Well, the third point is going to be the point symmetric to the y-intercept. So I'm going to sketch that real quick. I'm going to move this up just a little bit so I have a little room to work here. I'm going to sketch the graph real quick. Now, I only have 2 points at this moment in time. I'm going to get another one So be patient with me. So if that's the x value 2, and that's the y value 8, remember the y-intercept is right here. I better use a different color. So that's the point 0, 8, the y-intercept, where the curve crosses. We also have a point right here when x is 2, y is 4. That's the vertex. X is 2, y is 4. Well, remember, parabolas have a line of symmetry going through the vertex. That means every point to the left of the line of symmetry has a point to the right of that line of symmetry at the same y value. What do I mean by that? We have 0, 8, which is 2 units away. So going 2 units the other way, we'll have another point because they're symmetric. They're the same distance away from the from the line of symmetry. The line of symmetry goes through the vertex. Well, if this is 0 and it's 2 units away, this will also be 2 units away going the other way. The line of symmetry is at x equals 2. Adding 2, that becomes 4. And the y value is 8, so the y value is 8. So that's our 3 points. Our 3 points are 0, 8, 2, 4, and 4, 8. Now I can sketch in the graph. And that's what the parabola will look like. And that's a pretty good sketch of the graph. Now, I did want to go to Desmos real fast and put it in on Desmos. So here we go. This is the point 0, 8. This is the point 2, 4. And this is the point 4, 8. Notice that this is 2 units away. Our line of symmetry is right there. This is 2 units. That's 2 units. This is really important you understand that line of symmetry. Every point on the curve, on one side of the curve, has a corresponding point on the other side of the curve that's the same distance away from the line of symmetry. And that's how you sketch a parabola using the standard form of a quadratic equation.